Let's look at some special trig limits. The limit as theta approaches 0 of sine theta over theta equals 1, and the limit as theta approaches 0 of cosine theta minus 1 over theta equals 0. We can use these to evaluate limits. For example, the limit as theta approaches 0 of sine of 5 theta over 3 theta. Notice that what we're looking for is to have Notice that what we want is the angle in the denominator needs to be the same as the angle in the argument that is on sine. Right now, our argument on sine is 5 theta, but the denominator is not 5 theta. So we need to force the denominator to be 5 theta. To do that, we'll start by simply copying the limit for now. Leave a little blank spot. And we have sine of 5 theta over 3 theta. Again, we want the argument, which is 5 theta, to appear in the denominator, which means we need a 5 in the denominator. To do that, we'll simply multiply the denominator by 5. But if you do it in the bottom, we've got to do it in the top as well. We've got to put that 5 in the numerator. So we are essentially multiplying by 1. Which doesn't change the value of our limit, it just changed what it looks like. So now we have the limit as theta approaches 0 of 5 sine of 5 theta all over 5 theta, and I'm going to pull the 3 out. So here we're just rewriting the denominator. We're switching the 3 and the 5, and we're allowed to do that because multiplication is commutative. Now we pull the 5/3 out of the limit. 5/3 limit as theta approaches 0 of sine of 5 theta over 5 theta. This limit now is essentially what we had up here. Notice that the argument on the sine function is 5 theta. The denominator is also 5 theta. So this limit is going to go away to 1. So we have 5/3 times 1, which is 5/3. In our next example, we're looking at the limit as theta approaches 0 of cosine theta minus 1 over sine theta. Notice that using the cosine theta minus 1 limit, we also need theta in the denominator. Right now, we don't have that in this original limit, so let's force theta to be there. So again, I'm going to copy the original limit. And again, we're trying to make that numerator look like this limit. To do that, we need to divide cosine theta minus 1 by theta. If you do it in the numerator, we need to do it in the denominator as well. So as long as we're doing the same thing in the numerator and the denominator, we're not changing the value of the limit, we're just changing what it looks like. So now we have the limit as theta approaches 0 of cosine theta minus 1 over theta all over, I'm going to rewrite the limit and break that up using the quotient. The limit as theta approaches 0 of sine theta over theta. And now we can evaluate these separately. The limit in the numerator goes away to 0. The limit in the denominator we saw earlier is 1. So 0 over 1 is 0.